All right, let's have some more fun with Paralines. This morning, a poster on DIY Audio posted an idea of tracing the path in a Paraline by using string. And this is a really awesome idea, I think. And I just tried it out myself, and it definitely works way better than what I was doing, which was to take a circle and then fold it over. If you use string, you can get a really accurate idea of the length that the sound wave has to travel inside of the Paraline. Whereas when you're using what I was doing, which is to take a circle and to fold it over, you're missing the edge here. And even though the edge is only, this is, I believe, a quarter of an inch? Yeah, I believe this is a quarter of an inch. Even though this edge is only a quarter of an inch, it matters. So let's trace the wavefront in a Paraline. The way that this works is that where this screw is, the compression driver mounts where that screw is pointed, and then the sound goes radially, like in concentric circles, and then it bends over the Paraline and comes out the other side. So what I'm going to do is take this string and measure, I'm going to draw X's at various points, and then I'll trace that. So there's one point. You see the other point here basically goes to the edge. Also, if you look at my little eye shape, it's incredibly rough. I cut this using a hacksaw and spent all of 2 minutes making it. So I got 3 X's there. Make sure that's straight. You know, I'm a speaker guy when I don't have any string in the house, but I do have hookup wire. So that's what I used. Okay, so we got 1, 2, 3, 4, 5, 6, 7, 8. We got 9 lines. Now let's connect the lines. Okay, so that is the exit shape of this eye-shaped piece of wood. That line would be perfectly straight if I'd actually spent the proper time to make this eye shape proper, but you get the idea. So we have, let's see, so this path length right here, this piece of string or wire, we maintain the same path length across the entire exit. Do that again one more time, make that a little bit more obvious. Go like that. If we flip it over, so you see, and of course you flip it over, you get the same thing. But this is how you take the compression driver, which enters at one point, and then we get an exit, which is shaped like a ribbon. So it's long and it's skinny. Also, there's some other neat tricks you can do here. To me, these are really mind-bending, but it's some food for thought for you guys. You can bend the wavefront. So for instance, what I just showed you is going to have a flat wavefront because this line is flat. But I can make it, putting it on the side, I can make the wavefront curve by making this shorter. So by making this shorter, it's going to make the sound in the center arrive sooner than the sound on the edges. And what the effect of that is, because it arrives here sooner, it's going to lead the edges. You're going to wind up with a curved wavefront. And you're probably thinking, what's the difference between a flat wavefront and a curved wavefront? Well, a curved wavefront expands. So let's say you have this in your house or in your concert venue, and you want that wavefront to have some wide directivity. Then you use a curved wavefront. And you can also match the curve of the wavefront to your horn. One thing I'm kind of curious about, and only experiments will show, is whether you even need to attach a horn to this thing. I do kind of wonder if it's possible to curve the wavefront in the Paraline and then just leave the horn off entirely. If you've seen the videos that I posted playing music, you'll notice that there is no horn attached to it. All the wavefront manipulation is done inside of the Paraline. The last thing, which I think is incredibly cool, is not only can you curve the wavefront like this, not only can you get a round wave, you can also bend it in various directions. So for instance, you can bend it to the left, or you can bend it to the right. You could even have it converge if you wanted to do that, though I don't know why you'd want a converging wavefront. But the ability to bend the wave is pretty cool, and what you'll see in the Danley, in the Genesis horns, is that the Paraline is like, Paraline is like this, and then the wavefront bends down. So what this has the effect of doing is that you can put the speaker in the concert venue, you can put it up high and then bend the wavefront so the wavefront goes down into the seats in front, but you also have output all the way to the back of the venue. So it's to some degree, it's similar to tilting the entire thing, but you get to keep the whole thing straight. And in a home or car audio situation, this could be really handy. For instance, you could have a speaker which is in a wall, and you could have it with a flat face, but you could bend the wavefront so it's bent 45 degrees, so that the wave exiting the Paraline bends at the exit. So for instance, you could basically crossfire speakers which are flat on the wall, or even in the wall, or in your television set. You can do all kinds of weird things with this device. As always, post questions in the forum.